So John has a compost bin in the shape of a cylinder, so I've drawn the cylinder on there. And I've put the measurements on, 90 centimetres and 120 centimetres. He thinks he can fit 2 cubic metres of compost in it. Is he correct? So what we've got here are 2 different units of measurements. We've got the metres and we've got the centimetres. And we can't have them the same. We've got to have them the same, so we can't have them different. So we're going to divide each of these by 100 to make them into metres. So that then becomes 0.9 metres, and this becomes 1.2 metres. Okay? We then have to apply the formula, and the formula is pi times the radius squared times by the height. Okay? Pi, we know what pi is, it always is, it's 3.14, it never changes. Times by the radius. The radius is 0.45, yeah? Because the radius is half of the diameter. Times by itself, because that's what the little number 2 means, the little indices 2. Times by the height is 1.2. So we put that in our calculator. I'll get my calculator and we'll do it. So we've got 3.14 times 0.45 times 0.45 again times by the height, which is 1.2. What have you got as an answer? You've got
0.76.
It's not come up again on there. Why is that not working? There we go. 0.76 cubic metres. Okay? So will his 2 cubic metres of compost fit in there?
No.
No, they won't, because he's got way too much compost. He can't get it in. Yeah? So that makes sense, yeah? That's
But what if you did it the other way? And converted it afterwards into meters?
That's what I did, yeah.
Did you get the same answer?
So I got 7,600.
Yeah,
Oh.
Yeah, but then what you've got then, because you've divided that by 100 and that by 100, you can't just divide your answer by 100. Yeah? You have to divide it by more than 100. So it's always easier to change them at the beginning. Yeah? Then you're working with the same measurements all the way through, the same units of measurements all the way through. Makes it so much easier. Okay, makes it so much easier. So, no, unfortunately John can't fit all his compost in. Let's have a look at the second question then. Let's have a look at the second question. So basically for the second question you've got two sums to work out. You've got to work out first of all the size of the dice, and then you've got to work out the size of the boxes and see how many dice will fit into the box. Now, what's the tricky part of that question? It says that the dice is a cube. Let's say that's 5 on that side, with a side of 2 centimetres. So that's the dice. And this is the big box that she's got to put the dice in. And that's 12 by 10 by 4. You've been given the dimensions on the screen. Yeah? 12 by 10 by 4. So basically what you've got to do, you've got to work out the volume of that, and see how many of these go into that. Remembering that she's got 500 of these. Okay? 500 of these. So let's work out the volume of this. Well, we've only got one measurement, 2. But we know it's a cube. All sides the same on a cube. Quite easy. 2 times 2 times 2 times 2. Yeah? 8. The dice is 8 cubic centimetre. Then we've got the box. we need to work out the big box. Length times width times height. Doesn't particularly matter which way around you do the sum. 12 times 10 times by 4, 480. Okay. So far so good. So what we need to now work out is how many of these will fit in one box, would you say? How many of those go into one box?
60.
60. $60 dice in one box. She's got 500 dice. So how many boxes are we going to need? Ooh, another 60 dice in another box. So that's 120. Another 60 dice in another box. What have we got there at the moment? 240. Crikey, it's going to be a lot of boxes, isn't it? How many boxes do you think it's going to be? Or could we work it out a bit quicker? What if we take that and divide it by 500? See how many of those go into 500? That's what I would do, isn't it? Yeah? It's a bit easier, a bit quicker. 500 divided by 60 gives us
8.3.
So in other words, 9 boxes. Yeah, 9 boxes. We could have done it that way. We could have kept going. We would have kept going. But we decided to do it the division way. There we go. So dice 2 times 2 times 2, which is 8. The box 12 times 10 times 4, which is 480. 480 divided by 8 is 60. 60 dice in one box. Take the 500 divided by 60 is 8.3, so we'd actually need 9 boxes. Okay. So far so good. Brilliant. We're doing well. So, exam style questions, yeah, they're going to look a little bit like this. We're going to look at a few in a few minutes. But what they'll also do, what's been quite popular in the exam in recent times, is swimming pools. Okay? How much water is in a swimming pool? Because what we're coming up with now, if you remember when we did area, we started off nice, didn't we? With just a nice rectangle or a nice square or a nice triangle or a circle. And then we got composite shapes. We had a circle, half a circle on top of a square, or we had a triangle on top of a square, that kind of stuff. This is the same kind of thing. This is the same kind of question. And they use a swimming pool as a good example, purely and simply because of the shape of the swimming pool. Which is that shape. If you looked at it, yeah, it's that shape. There's the deep end, there's the shallow end. Okay? So what we've got to think to ourselves now, because how much water, volume of water is in a swimming pool? This is a difficult one because look at the shape. It's a crazy shape, it's a funny looking shape. How are we going to work it out? So what we do here, like we did with the area questions, we split that shape up. Like that. Okay? So what have we actually got? We've got a big rectangle here and we've got a triangle there. Okay? So we've made 2 shapes. Okay? We've made 2 shapes. I'm going to redraw it on here. Let's make it a little bit easier to understand. So here's the deep end. There's the swimming pool. There's the shallow end. Okay? So the question's saying that the length of the swimming pool is 25 metres. Okay. The shallow end is 1 metre. And the deep end in this instance is 2 metres. It also tells you in this bit of information here that the swimming pool is 16.8 metres wide. So if we were to imagine this as 3-dimensional, that's a 2-dimensional picture. If we were to imagine it as a 3-dimensional picture, that's what the swimming pool would look like. Okay? And this bit here is the 16.8. Okay? So far so good. So all I've done, I've changed that picture from 2-dimensional to 3-dimensional. That's all I've done. So you can kind of visualise it now, as though you're looking down on the swimming pool from above. So we get our imaginary pen and we draw ourselves a little line along here. Okay, it's not drawn to scale, obviously. So what have we got now? We've got a rectangle here and we've got a triangle here. Two sums. So we're going to work out the rectangle first. The formula to work out the volume of a rectangle is the length times the width times the height, or in this case the depth. It's the depth of the swimming pool. The length of the swimming pool is 25 metres. The width of the swimming pool is 16.8. The depth of the swimming pool is 1. That's our first sum. And that will give us the volume of that rectangle. Obviously 3-dimensional. Yeah? 3-dimensional. So what does that give us? It gives us, I've not got it on the screen there, I'll have to work it out with it.
420.
Cubic metres. So now we've got to work out this triangular bit here. So we remember the formula. It's the base times the height divided by 2. I put that in bracket because we've got to do it first. Times by the length. Okay? Doesn't particularly matter which way around you do this, but we're going to go for the base of 16.8 times by the height, which is 1. There it is. Divided by 2 and then multiplied by the length of the pool, which is 25. Okay, so that's the width of the pool there, which is actually the bit, if you remember, if you can imagine that stood up, that's the base of it, times by its height, which is 1, divided by 2 times by 25. So we do that as a sum, which gives us, let's go, 210. Cubic metres. So that's the rectangle, that's the triangle. We add them both together. So there's 630 cubic metres of water in that pool. Does that make sense? Yeah, does that make sense? So there we go. So there's the answer on the screen now. Work out the volume of the rectangle, which is a cuboid. Then work out the volume of the triangle, which is a prism. We added them together. There's the sum, 25 times 16.8 times 1. I used slightly different numbers, but that doesn't particularly matter. 1 times 25 divided by 2 equals 12.5 times 16.8 is 210. 420 plus 210 equals 630 cubic metres, yeah? There's also an easier way to work that out, but it's a little formula that you've got to remember, and it's this. Length times width times average depth, okay? Length times width times average depth. So let's say, different swimming pool, 25 metres long, 12 metres wide, so instead of 16.8 there, it's going to be 12. Okay, the shallow end is 0.5, so instead of that being a metre, it's 0.5. And the deep end is 3 metres, so instead of that being 2, it's 3 metres. Okay, now we don't need the green imaginary line now, because we're going to use that formula. And that formula is length times width times average depth. So the length is still 25. The width now is 12. And the average depth, so now we're thinking back to averages. How do we work out the average of two numbers? How do we work out the midpoint of two numbers? Well, we add the two numbers together, so we've got 3 for the deep end, plus 0.5 for the shallow end. So 3 plus 0.5 equals 3.5. Then you divide it by 2 to find the midpoint, remember, or the median. So 3.5 divided by 2, that gives you 1.75. 25 length times by 12 width times by 1.75 the average depth, which would then give you your answer. A bit easier to work out, a bit quicker. This is your tricky bit, working out the average depth. So it's asking you to think back to how you worked out an average of two numbers. It's like the midpoint. Do you remember when we worked the midpoint out, we did averages? We had the two numbers together and then divided by 2. Boom, there you go. Length times width times the average depth, which is the deep part added to the shallow part, divided by 2, which gives us 525 cubic metres. Does that make sense? Yeah? Using that formula. If you can remember the formula, brilliant. It's quicker than working out the rectangle, quicker than working out the rectangle and the prism and adding them together. It's a lot quicker, but you've got to remember that bit, the average depth bit. Okay? So, bearing what we've just learned, how would we put this into an exam style question? Well, they give you something that looks a bit like this. Okay? The swimming pool at the local leisure centre is 25 metres long, 12 metres wide, 0.5 at the shallow end, 2.5 at the deep end. Information about the pool. A cubic metre is equal to 1,000 litres of water. 1, 2, 3, 4 parts to this question. Work out the volume of water in the pool. Calculate how many litres of water in the pool. Water is pumped in at 4 litres per second. How long to the nearest hour and minute will it take to fill the pool? The water company charges 23 pence per litre of water that's used. The pool must have the water replaced twice a week. How much will it cost to change the water per week? Big question. Okay, nice big question. Let's have a go at it. Let's get the first bit first done. Let's do the first bit. Let's work out the volume of water in the pool first.
Rather than